There, hi, and welcome to Shared Learning. Learning new things every day. I was on Google Earthing, and there was a picture I found, and there was this word, limnology. I have never heard this. It's the study of inland aquatic ecosystems. The study of limnology includes aspects of the biological, chemical, physical, and geological characteristics and functions of inland waters, running and standing waters, fresh and saline, natural and man made. This includes the study of lakes, reservoirs, ponds, rivers, springs, streams, wetlands, and groundwater. A more recent subdiscipline of limnology, termed landscape limnology, studies, manages, and seeks to conserve these ecosystems using a landscape perspective by explicitly examining connections between an aquatic ecosystem and its drainage basin. Recently, the need to understand global inland waters as part of the Earth system created a subdiscipline called global limnology. This approach considers processes in inland waters on a global scale, like the role of inland aquatic ecosystems in global biochemical cycles. Uh, yes, I didn't dive into that too much, but this might be really well related. Everest's highest glacier rapidly losing ice. Study. Kathmandu. Ice and glacier near the summit of Mount Everest had took millennia to form has shrunk dramatically in the last 3 decades due to climate change. A new study has shown. Yes, climate change. Not human-made climate change. They just talk about climate change. Which is quite correct. The South Col Formation may already have lost around 55 meters of thickness in the last 25 years, according to research led by University of Maine and published this week in Nature. Carbon dating showed the top layer of ice was around 2,000 years old, suggesting that the glacier was thinning more than 80 times faster than the time it took to form, the study said. The South Col Glacier is around 7,900 meters above sea level. So I just wonder how many of those days they have there where it's like, really warm. Everything starts to melt in this height. Somehow it's a little bit hard to believe that it would get so hot up there that they really would start to melt. As the glaciers shrink, hundreds of lakes have formed in the foothills of Himalayan mountains that could burst and unleash floods. Nepali climber Kami Rita Sherpa, who has climbed Everest a record 25 times, told AFP Saturday he had witnessed changes on the mountain firsthand. We now see rock exposed in areas where there used to be snow before. Not just on Everest, other mountains are also losing their snow and ice, and it's very raining. So now, about mountains, mountain water, glaciers, underground water currents, telluric currents, and all these kind of things. Electric universe. So Andrew Hall and others, they are talking about the water is flowing towards to where the dragon came. And this is now fractal burning into wood surfaces. And you can actually see from where the dragon, in this case, the heat is coming. And as you would expect, it's the most, maybe I change color. The deepest is here, and it continues to grow this way, and this is meeting, or this is growing that way. And notice how every now and then here there's like fire reaching. Now I have to scroll a bit back because I wanted to show you something really important. Which obviously didn't happen too many times in nature, or it actually had, but not in the Alps probably. Too many times I still search for those, for this kind of hint. But the thing is, check it out what happens when this meets this. The whole channel, the whole distance will light up. Check it out. Now. So if you would somehow scale that up, you could probably think that once our riverbeds, they have been on fire to some degree. I mean the big ones, the big riverbeds. This would explain all these kind of minerals and stuff what we find in the groundwater and all these kind of things. Yeah, there's your riverbed. Let's just enjoy this for a second. It's so nice to watch. Ring of Fire. And the other thing is what I thought about, as you have seen now many times here, wettens surface, there has to be this water. And salt water would also work. But he uses this, what was it? Baking soda. So now if the charge is increasing, the water will rise up from the ground. We might experience this kind of liquefaction happenings. So then the water rises up, and if there's like the overall charge is increasing, like crazy things going on the sun and our shifting poles on Earth, so then we would have this kind of water on the surface or much more close to the surface, and there is like salty mining going on all over Europe. Germany, Switzerland, France probably too, and all those others, they are digging salt out of the ground, so it is there. It just has to mix up with the water, and then you get salty water, and the conductivity is increased really rapidly. And it will search the path of least resistance. So if there is a big amount of groundwater or like big rivers or these kind of things, they might be affected the first. And notice what happens when they touch each other. Now, for example, in the Alps, there are many valleys. They aren't attached. They're basically like this one arm of this dendritical pattern. So if those get connected, there might be a different landscape after this.
So I thought I had the camera running, but well, that's.
Yeah, and he's doing these kind of nice things. Or yeah, there was this commercial, and he's filling this up with epoxy and this kind of things. Some of them glow in the dark.
Is this still cool? You're darn right it is. So I just wanted to show you that. So that's the walnut. Here's cherry. And again, fine detail, maybe not as much as the maples typically.
So now let's have a look at that quickly, and I show you something else. Let's just go over here, and you can see the exact same patterns all over the place. Yeah, there's just the water. It goes to that direction, okay? So we might be up in the hills. 4 kilometers in depth. So it might be in the ground water region after all. Yeah, but I leave it here. Thanks. Bye.